Next important passive electronic component after resistor is the capacitor, which can be used to store electrical energy. There are various types of capacitors available in the market, like electrolytic capacitors with a thin layer of electrolyte connected to metal plates, capacitors using paper as dielectric, capacitors with air as dielectric, and ceramic capacitors. Each one is for a different purpose. There are also capacitors in which the capacitance can be varied, known as variable capacitors, often used in tuning resonance circuits. Capacitance is measured in farads, microfarads, nanofarads or picofarads, depending on the value from higher to lower. High capacitance in circuits for smoothing out ripples in rectified direct current uses several thousand microfarads. Farad, being a large unit, is seldom used. A typical tuning capacitor in radios may be rated at 500 picofarads, 500 pf. A capacitor is said to have a capacitance of 1 farad if it can store 1 coulomb charge at a potential difference of 1 volt. There are few symbols associated with capacitors. This symbol 2 lines is for a fixed value capacitor, like the ones which I have shown. And this is a polarized capacitor. Electrolytic capacitors have positive and negative poles which are to be connected according to that in the circuit, while ceramic and paper capacitors or air capacitors do not need that. And this is the symbol for a variable capacitance, mostly used in tuning, and sometimes there are presets also. You can use a screw to change the capacitance and then fix it like that. It will not be a tuning knob in some of the preset capacitors. They are usually smaller ones also. You may need to combine two capacitors to increase the capacity. When two capacitors are connected in parallel, the total capacity will be sum of the two capacities. Suppose you combine 2000 microfarad capacitors in parallel, then it will be acting as a 2000 microfarad capacitor. If you combine in series, the capacity will be lower. While capacitors are combined in parallel to obtain higher value of capacitance, as in filtering circuits, series connection is to achieve higher working voltage, though the resultant capacitance will be lower. As in the case of resistors, inverse of the capacitances have to be added and the inverse of the sum obtained to get the resultant value of capacitance. The equivalent capacitance will be less than that of any of its components. These are a few electrolytic capacitors which I fished out from my recycle bin, or rather electronic junk box recently. The focus will be on this bigger one. You can see that this has a higher capacity rated at 1000 microfarad. The working voltage is given as 50 volts. And you can see that there is a minus sign here. That means this particular lead is for negative electrode and this one is positive. Another way of finding out is by the usual notation. The positive one will be longer. This is followed for most of the electronic components like diodes. Filter capacitors are used to smooth out the ripples in rectified DC. That is, when you use a diode, rectifier diode to rectify AC to DC, there will be ripples. Ripples in a rectified current can be smoothened by using high value capacitors like this. This is 1000 microfarad. You can use 2000 also, and multiple capacitors in parallel as well to smooth out the ripples in rectified current. Electrolytic capacitors have one plate as an aluminum or tantalum plate with an oxide dielectric layer. Second plate for an electrolytic capacitor is a thin layer of electrolyte which is connected to the circuit by another foil plate. Though electrolytic capacitors have very high capacitance, they have poor tolerance, high instability, gradual loss of capacitance, especially with high ambient temperature, and high leakage current. Electrolyte leakage from poor quality capacitors could damage the printed circuit board as well. There could be self-degradation if left unused for a long period, like a year, and might lead to short circuit when full power is applied. At high strengths of electric field above the nominal working voltage of the capacitor, the dielectric separating the two plates of the capacitor might become conductive. This is known as breakdown voltage of the capacitor. Maximum energy which can be stored in a capacitor is limited by the breakdown voltage. The air gap between plates of capacitors used in high voltage vacuum tube circuits need higher spacing to prevent arcing. Capacitors with mica as dielectric between the capacitor plates have much higher breakdown voltages than air capacitors. Ratings of capacitors in general applications may range from few volts to kilovolts. Dielectric has to be thicker for higher voltage rated capacitors, making them larger. When a capacitor is connected to a circuit with direct current supply, it will allow current to flow till it becomes fully charged, usually a fraction of a second, depending on the capacity of the capacitor. Once fully charged, dielectric does not allow further flow of current through the circuit. Initial flow of current is only to charge the capacitor plates and not through the dielectric when the voltage applied is below the breakdown voltage. Beyond the breakdown voltage, the capacitor gets damaged and may produce short circuit. When an alternating current is applied to a capacitor, as it changes polarity with a fixed frequency, the capacitor keeps on charging and discharging. Here the current continues to flow through the circuit, though electrons do not cross the dielectric material of the capacitor. In effect, a capacitor blocks DC while it allows AC to flow. Higher area of the capacitor plates increases the capacitance. In other words, capacitance is directly proportional to the area of plates. Relation between the spacing and capacitance is the other way around. Closer the plates, higher the capacity of the plates to hold charges, because electrostatic pull on the electrons collected at the negative side of the voltage source will be more. So, capacitance is inversely proportional to the spacing between the plates. But too close plates will cause arcing at high voltages. Dielectric constant of the material between the plates is also important. Compared to vacuum, air has a dielectric constant of 1.0006, while mica has a dielectric constant ranging from 5 to 9. Higher the dielectric constant, higher the capacitance. This picture illustrates different types of capacitors. From left to right, they are multi-layer ceramic capacitor, ceramic disc, multi-layer polyester film capacitor, tubular ceramic capacitor, polystyrene capacitor, metallized polyester film capacitor, and aluminum electrolytic capacitor. In the next video, we'll discuss about another passive electronic element inductor.